Welcome back, YouTube. This is Coach Carr here, your favorite YouTuber. This video here is on page 1 and 2 of our note packets. It's on similar right triangles and geometric mean, and I hope you enjoy. Alright, and just like with any given lesson, we have a learning target and a success criteria. Well, the learning target is a little bit ambiguous. It just says prove theorems about right triangles. But the success criteria, I want that to be a little more specific for you, and you'll be successful when you know what geometric mean is and when you can use it in similar right triangles. Alright, so at the top of your note packet, it's saying, what is the vocabulary for geometric mean? Well, what I want you to write is that it's a special type of average where we multiply the numbers together and take the square root. So the example that I gave you on here is it says find the geometric mean of the numbers 2 and 18. Well, first thing I did was I multiplied them together. So 2 times 18 got me 36. Now, there's two numbers, so I want to find the square root of that number. So the square root of 36 is 6. So the geometric mean of those two numbers would be 6. Alright, so now we are looking at number 1. This one is saying, given the figure below, how many similar right triangles are there? Well, if you notice with the picture, they actually have this altitude inside of there to kind of break up the big triangle. So if you don't remember what an altitude is a line that's going to start at a vertex, go across, and make a right angle. So with this, cutting this big triangle, you have this small one here, this about a medium-sized one here, and then the full triangle altogether. So what we have is we have 3 similar triangles. Now, what is the similarity criteria that we use for this figure? Well, I'm looking at this stuff that they gave me. So I was told that I have right angles all throughout. So the big triangle has a right one, the small one, and the medium-sized one all have right angles. So I found at least one angle between them all. Now, if you notice, let's say if I looked at the small triangle, well, it uses this angle here, which is also used by the full triangle. So because of the fact I found at least 2 angles that would be congruent between both of them, that means I can use the AA postulate. So angle postulate. Now, I'm going to skip this question for right now so that we can do these boxes. So what they want us to do is kind of actually break up the triangle. So we're going to draw the small triangle, draw the medium one, and draw the large one so we can see what sides could potentially go with each other. So the way I'm going to draw it, I'm going to draw my small one first right here. And all of these are going to be dealing with right triangles. So I drew my small triangle, or small right triangle to be exact. Now with the small one, the only thing I know about any of its length is that this portion here has been labeled as C. So with the way that I drew it, I have it drawn so that I had the long part of the right triangle and then the short one on the bottom. So if I were to rotate this, C would be right there. So for me, with the way that I have it drawn, C would be there. So now I'm going to draw my medium-sized triangle, and I'm going to try to make it look very similar to that one where I have, it's a little bit bigger, but I'm going to keep my longer side over to the left and my shorter side or shorter leg on the bottom. Now, when I look at the medium-sized one, if I were to rotate it to the left, my long side would be D, so I'm going to have D over here, and then my hypotenuse would be A. Now, I know it's the hypotenuse because it's directly across from the right angle. So directly across would be my hypotenuse, and we said for the medium-sized triangle, that's where it would be. Now, draw and label the large triangle, so that's the full one. I'm going to draw a little bit bigger one, and again, I'm going to try to make it look the same as my other ones. So in this one, with the full one, my hypotenuse would be directly across from it. So, and they told us the full length of our hypotenuse was B. So B would be right there. Then, if I look at it, my longer leg in the full triangle is A. So the way that I redrew it, I would have my A be here on the left. So now they want us to do, now I can start answering what is the proportion we can gather from this figure. So I want to look at the two different size triangles that I drew and see which ones have side lengths that I can say are similar. So in my small triangle, the only thing I found was the small leg. Well, I don't have the small leg for the medium or large triangle, so I am not going to be using this one. Now, if I look at the other two, however, with the medium and the large triangle, I'm both looking at the large leg and the hypotenuse. So this is the one that I can actually create my proportion. So what is the proportion we can gather? So the way I'm going to do this, I'm going to look at my, let's say if I looked at my medium one, I'm going to say D over. Now I look at the larger triangle and see what D goes with. So D went with A. So I have D over A equals, now I'm going to look at my medium one again. I'm going to have my A up top. And A went with the other hypotenuse, which was B. So if I were to actually solve this, the next thing I would do is do my cross multiplication. And this would make it so I get A times A, which is A squared, equals D times B. So this is dealing with geometric mean because we said that when we take the average of what we multiply together and then take the square root. So if I wanted to get A by itself, A squared, well, the way you get rid of a square is through a square root. So what I would have is A equals the square root of dB. So that would be technically my proportion that we can gather from this figure. All right, so now we're going to finish page 1 together. So I'm looking at number 2. We're going to do part A and part B together. Now, first, let's look at part A. Now, again, this is one where we have this, 3 similar triangles. I know this because of the right angles in there and the fact that they share other angles, so I can use that AA postulate. So first thing that I notice is that they say that the full length is 25, and this portion here is 9. So I can actually find out what this portion is here by doing 25 minus 9. So 25 minus 9 gives me 16. So I know that this portion here is 16. So now that I've labeled that, I'm going to go ahead and break my triangles into 3 different sections. So just like I did in this example up here. So I have my small triangle first. So I'm going to kind of set it up the same way I did last time with the longer leg on the left. Now it doesn't matter if you do that as long as you just make sure the small, medium, and large are set up the same way. So if I did this, the shorter part of this triangle here, the small triangle, the smaller leg was on the bottom of it. So I'm going to have my 9 right there. And then the variable I'm trying to solve for is the hypotenuse. And again, I know the hypotenuse is there because across from the right angle is going to be the hypotenuse. So right here, I would want to label that as X. So now I'm going to draw my medium size one, and I want to make it look the same as the last one except bigger. So I'm going to make it so that the smaller leg's on bottom, bigger leg's on the left. So when I look at the medium size one, I'm just looking at this one right here. And the only thing I've been given is this 16. Now the 16 would be the longer leg, so I'm going to put that right here. That is the only thing I know about this medium-sized triangle. So now I'm going to draw my big one. And now I want to label the things I know about it. So first thing, across from the right angle is going to be your hypotenuse. So I know my hypotenuse is the full length, which is 25. So I have 25 right there. And then the x is the shorter leg between the two. So I'm going to put that down here. So I want to look at which triangles have a number or a variable in the same spots as each other. So the ones that have that happen is this one and this one. So those are the two I'm going to use. So I want to set it up with which ones go with which so that I can do my cross multiplication. So let's look at if I looked at the hypotenuse for the small one, that was labeled as x. Well, x would go with the 25 because that's the hypotenuse on the big one. So x over 25 equals, now I'm going to look at the short leg here, 9. And the 9 would go with what I don't know here, so it's labeled as x. So now you would do your cross multiplication. And so x times x is x squared. 25 times 9 gets me 225. Now, I can't have the squared with the x, so I'm going to try to get rid of it. And the way you do that is by finding the square root. So x equals the square root of 225. And when I do that, I can put that in my calculator, and I would get x equals 15. So in this case, the variable x would be 15. All right, so that was the first one here, part A. Now let's look at part B. Now, part B, just like this one, they tell me the full length of this hypotenuse, but the one thing that they don't tell me is how big this portion is. So again, I can do my 25 minus 12, and that's going to get me 13. So I know that this portion here has a length of 13. So now I'm going to break it up just like I did the other ones. So I'll have my small right triangle first. So again, when I'm looking at the small one, across from the right angle is my hypotenuse. So my hypotenuse in this case is labeled x. That's what we're trying to solve for. And the short leg in the small triangle is 12. So with the way that I drew it, 12 would be right there. Now, let's draw the medium-sized one. So with this medium-sized one, so if I'm looking at this triangle right here, the only thing that I've been given is the 13, and the 13 is the long side. So that's going to be right here. That's the only information I was given on any of these sides. So that's the only thing I can label for that one. Now with the big triangle, I'll draw that now. With the big triangle, I know what the hypotenuse is because if I went directly across, it's the full side, so directly across from the right angle. So this side would be 25. And then x is the short leg, so I would just put it right here. So I got to figure out which ones can go with each. So with the small triangle, I have the hypotenuse and the small leg. Well, with the large triangle, I also have something for both of those. So these are the two I'm going to use to set up my proportion. So again, I can do my hypotenuses. So x goes with the 25. So x over 25. And then 12 would go with the x, because they're both these short legs in each of their respective right triangles. Okay, so now do your cross multiplication. So x times x and 25 times 12. So x times x gets me x squared, and 25 times 12 gives me 300. Oh, like the Spartans? Yeah. Now, to get rid of the square, we have to find the square root. So I would have x equals the square root of 300. And when I do that, I would get x equals 17.3205. So I just wrote multiple decimals because they didn't tell me how many decimal places they wanted me to have my answer to. But in this case, your answer would be x equals 17.3205. Alright, so the last problem I'm going to do with you guys for this video is number 3, part A. So with this one, pretty similar to the ones that you've been doing. The only main difference is you actually have to find two variables this time. So what I'm going to do to start off is actually the same thing that we did with the other ones. We want to take this, break it up into our 3 triangles. So we're going to have our small triangle, our medium-sized triangle, and our large triangle. And we're just going to set up each side so we know which ones to put with it. So if I look at the small triangle here, the A goes with the shortest side. So with the way that I drew it, that means A would be right here. B is my hypotenuse for the smallest one, so I'm going to put that there. And then the other side, I know the longest side there, which is 12. So for the first one, that's where each of the sides would be. Now if I look at the medium-sized triangle, now this one is a right triangle as well. The reason I know this, here, if this is 90 degrees, well, to make a line, it has to be 180. So this side must also be 90 degrees. So the small side would be 12 in the medium-sized triangle. The longer leg would be 16, so I'm going to put that there. And then the longest side of this one would be across from the right angle, and that would be 20. So our hypotenuse for this one is 20. Now, the big triangle here, in the big one, the shortest leg was B. The longer leg was 20. And then the hypotenuse is the 16 and the A. So the full length is actually 16 plus A. So what I'm going to do is first figure out which two triangles I want to use. Now, if you notice, the medium triangle has an actual number for each side. So I'm going to go ahead and use this one to solve for A and B. Now, the other triangle that I am going to use is the larger triangle. Now, I also could have used the smaller one, but I just want to use this bigger triangle as well. So, first thing I want to do is decide if I want to solve for A or B first. I'm going to go ahead and solve for B first. Now, so if I look at it with the B, the 12, the short leg, goes with the larger leg where I have the B. So what I want to do is do 12 over B. So I got the 12 from this short leg, and I paired it with this other short leg. Now, I don't want to use the hypotenuse because that one has a different variable. So I can't combine a variable that has A and a variable that has B. So what I'm going to do is look at the other leg where I have a number for both. So since I started with 12 on this one, I'm going to start with this triangle again. So I have 16, and 16 goes with the 20. So now I'm going to do my cross product. And 16 times B is 16B. And 12 times 20 is 240. So I'm trying to get B by itself, so my next step here is to divide by 16. And B equals 15. So we have solved for B. Now the last thing to do is they want us to find all the missing variables, so now we're going to solve for A. So to solve for A, basically doing the same thing. So if I did this, the 20 is the hypotenuse on the medium one. That's going to go with the hypotenuse of this one, which is 16 plus A. So I'm going to have 20 over 16 plus A. That is going to, now I'm going to use the side that I have a number for both, just like we did last time. So that's going to be the 16 and the 20. Now you do your cross product. And 20 times 20 is 400. And then remember, when you see this, this means 16 times 16 plus A. So I have to distribute 16 into both of them. So what we would have is 400 equals 16 times 16, which is 256, plus 16A, because it distributed into both numbers. Now, next step would be to subtract 256 from both sides, because I'm trying to get A by itself. 400 minus 256 is 144. So 144 equals 16A. Next step would be to divide by 16 to both sides. So that 16 cancels out over here. So A is equal to 9. That's the end of the video. Thank you so much for watching. Make sure that you do exit slip number 1. That is the most important thing. But also make sure you like and subscribe. And if I ever get merch, buy it.